Hello everyone, welcome to our presentation on the final task IoT pilot projects. And my final task project today is IoT temperature monitoring system, which demonstrates an app to UI architect where a web application that collects, stores, and visualizes temperature data from IoT devices. The system includes a temperature sensor here, a backend API to handle data injection and query, a database for storage, a user-friendly interface to display real-time temperature readings and historical data trends. To be more detailed, the system has a BlackBerry PPW act as an app device, and it communicates with a Node.js address JS backend on cloud using HTTP requests. Then the Pico W collect the data from the temperature sensor here, and the Pico W send it to the cloud via HTTP GET request, and the cloud backend receive this data through a REST API endpoint that accepts a very parameter value. Then Grafana is used, as you see. Grafana dashboard is an open source tool that provides an interactive dashboard for real-time and historical data visualized. So I use the Grafana dashboard embedded to our web page here, as you can see. So that's all the briefing of general information about my project. So our presentation today will follow template evaluation from carry from the topic number 1, embedded system device, to the topic number 6, user interface. So let's jump to the first topic, embedded device. Thank you. Hi, in this first topic about embedded system, I will show you a sample implementation using Walkway to simulate the edge devices. Actually, I will have real devices, but it take time to take turn device from other members, so I decided to use edge simulation from Walkway to complete this part. And the purpose of this sample is to demonstrate how the data can be collected from the edge to the cloud. As you can see in the right window, this is a diagram show how the embedded device wire and connect, wire and setup, and the system device contains 2 components. The first part is MCU, which is a Raspberry PPW, and the second part is analog input device, which is a temperature sensor here. And as you can see in the left window, this is the main program file is responsible for all MCU operation. Here is the necessary library needs for the program, and here is the constant, like some kind of web Wi-Fi SSID and Wi-Fi pass, the base UAL data endpoint needs for the function data send, and here is how the wiring and setup, as you can see here. And here is some parameter needs for the breath temperature functions here, because we need to convert the analog signal to the digital signal. And here is the functions for sending data, which construct and send data in HTTP GET request containing data in a very parameter. And here is connect Wi-Fi functions. I would say this function connects Pico W to wireless IP access point, and the connection process is shown in the console. After successful connection, the function shows the LAN IP config if debugging is on. And the last one is the main program here, which completes the rest of the initialization and start the routine like main loop. This is how the embedded system device works. I will start the simulations here. As you can see, it will connect into the Wi-Fi, and connect this console logs here. It sends the temperatures 26 and receive a response contents like the data has been write to the cloud here. And let me check if the data were written correctly or not. 26 here. Let me check in the database. As you can see here, the record for the 26 temperatures were recorded successfully in the database in 1446. Okay, that's it. Hi, in this second topics is resource allocation and benefit. I will talk a little bit about the resource that I allocated for the projects and some benefit they may bring. Here, as you see, this is the technology stack that I apply for the projects from the front end to back end and the DevOps here. So about the operating costs, I would say my system leverage some free and open source resources to minimize spend. For example, as you see here, I have used the Azure Student VPS for cloud and server, which is a cloud service with free credits for students and offering high availability with no upfront cost. For the database, I use InfluxDB, which is an open source time series database optimized for the last data injection. For the backend side, I use Node.js and Express.js library, which is an asynchronous open source runtime perfect for real-time backend processing. For the web server, I use Nginx, which is also a free and lightweight HTTP server used for reserve proxy and load balancing. And finally, for the UI front-end side, I use Grafana, which is also an open source visualization tool providing customizable dashboard for analyzing temperature trends. Finally, I think that some benefit they could bring for the projects is that these resources ensure the scalability, reliability, and security. For example, Azure proposed infrastructure support 24/7 operation, while InfluxDB efficiently handles large volume of time series data. And by using open source tools, I think that I have achieved a cost-effective and powerful IoT solution. In this third topic about cloud service, I will talk a little bit about the cloud environment that's hosted in my Azure VPS. I have installed and loaded some latest version of the software in my IoT pipeline. For example, let's come to my virtual machine for a node is version 23.1, which is power and the backend and enabling efficient data processing API handling for InfluxDB. As you can see here, InfluxDB version 2711, which is a database optimized for storing time series data like temperature readings. For web server Nginx, I have here version 1.24, which is handle HTTP traffic, ensuring secure and smooth communication between front end and back end. And some other service I have installed is Grafana. I have here version 11.4 and Curvo. I have here version 8.5 and the last one I think system D CTL. So I think these components are prefigured to work together seamlessly with public port 80 and 443 open for global accessibility. So that's it for the topic. In this fourth topic, I will talk about the cloud service configurations. The first one is 24/7 operations. Services are configured with systemd to ensure the automatic startup and recovery in case of failures. Another purpose is that resource allocation on Azure ensures to interruptions even under high workloads. And here is how I make my DB API service, doc service as 24/7 service operation. The first step is that I set the systemd configuration at etc systemd system. Then I create a service file by this command and I add below a script for the configuration. Then let me verify which service now is running. So as you can see, my service DB API service now is activating and auto restart. Also, you can see another service like Grafana and InfluxDB. Okay. And about the connectivity and firewall configurations, for the public port 80 and 443 connectivity service, listen at the public port. The port 80 HTTP and the port 443 HTTPS are open for front end and API communication. I also did the configuration for Nginx to on port 80 and 443. I also use the server port to get SSL certificate for my domain at here. So let's see my configuration. Here. So let me verify that Nginx is listening on port 80 and 443 or not. You can see here. So about the firewall rules and routine, the firewall allowed in route traffic properly to public port properly. So Nginx route traffic appropriately to the backend of static web interface. So here are what I did to get the firewall configuration. So let me verify if firewall allowing traffic on port 80 and 443. As you can see here, so let me check a little bit about the SSL in my domain. Here, as you can see, the connection is secure. Okay, and my public port HTTP is okay. And about the database service, you know, InfluxDB its database service is set to other service can utilize it for storing data. So I would like to verify for this section by below step. The first one, I will check that InfluxDB is running or not with this command. Okay, you can see the active running, service enable. Then I want to ensure that InfluxDB is listening on the correct port is 8086. Okay, it's already listened on this port. So I will test if the writing data it can write to the database or not. Let's see. The endpoint embedded, so I will write the value 85 and it's returned the 85 is written. I will check it again in the database. As you can see, the value of temperature 85 now is written successfully to the database. So that's it for the topic. In this fifth topic about the backend side, I will talk about the backend, what backend do, which is it's collecting data, received data can be observed in the backend log console after the data is written to the database. And in this my projects, is implement REST APIs using Node.js runtime and Express.js library. The idea is that one API endpoint is created to data collecting. It will be set as a service in the cloud, and the API is then public by using Nginx web servers, reverse proxy. And as you can see here, this is also API with endpoint embedded. This is an API endpoint listen to the HTTP GET request on the path API v1 embedded. It expect a very parameter call value which contain the value that I wish to store the temperature data into the database. And another endpoint for data retrieval data point from InfluxDB that you can see here. And this API endpoint is a GET API designed to retrieve temperature data stored from the InfluxDB database. It's query data from a specific bucket, filters it for the design, measurement, and field, as you can see here, and return the result in a JSON format. So that for that we can easily use for the front-end visualizations. But in my projects, I don't use this. I just apply the Grafana for UI interface. So I can show you how this endpoint works. This is endpoint embedded to write the data. I write 81. Okay, let's see in the database. Table. So now 81 is written to database, and let's check the endpoint term, which can retrieve data from the InfluxDB. The latest temperatures here and all the data here, and this can be the backend log for the check-in, or we can apply to front-end UI also. And I think that's it for the topic. In this last topic about user interface, I will show you how the temperature from database can be visualized. I already use Grafana, which is an open source tool that provides an interactive dashboard for real-time and historical data visualization. For Grafana, it works in default port 3000. Here, you can see the dashboard here. And I just embedded this dashboard into my web page by using an iframe containers. You can see here my UI also using HTTP and a little bit CSS also. You can see an iframe here and the embedded link here for dashboard, one for the current temperature, one for the historical temperatures, and it now is on my web page. The last previous temperatures will be updated when I refresh the page. Now it's 81. Also, you can see the dashboard in my port 81 and in HTTPS also. Now it's available. So I think I have learned a lot through this final task because it leverages cutting-edge cloud technologies in software tools like Azure, Node.js, InfluxDB, Grafana, blah, 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 and I have changed to practice by myself a lot. And I think these projects may need more time to improve some features like with Grafana, I can have feature like sending alert function to the user or the data validation. It may need to implement a middleware to verify the data before sending it to cloud. Or another features like implement authentication, like using some first services like Hook from Firebase to Deloitte and user authentication. And last but not least, I think this project can extend more about the perfect multiple sensor, like not only one sensor, but more sensor from more other locations. And I think I will think about the reason why I start the projects, like how I can earn money with the project. So I target to make this application to some private sauna in Finland. So it's maybe get the profit if the projects be more complete and perfectly. So again, thank you for your time to see my video. And if you have any issue or inquiry, please contact me via my email here. Basically, I have my projects on my repository in GitHub. So thank you and have a nice day.